This is a nice little segment I got from the Mars Reconnaissance Orbiter uh, as it just kind of flies over one of the larger craters on Mars. It's just absolutely gorgeous. But I want to thank and welcome everyone to the 16th, I think our first December meeting for the regular membership of the Astronomy Association of San Diego. And I am Steve Hallman, your host, and let's get started. Dave, if you'll take us to the next slide. So, as you all know, of course, COVID-19 has been playing havoc with our many activities where we try to reach out to the public, but you can stay up to date on the latest information on which of our activities are active and current by going to our website, SDAA.org. If you type in SDAA into Google, we are the first thing that comes up, so that we're easy to find. Go to the calendar and it'll list all of our events on the calendar. So I'll encourage you all to do that. Also, we have a Facebook, Twitter, and Instagram feed. So I would encourage you to go to Facebook, Twitter, and Instagram and search for SDAA or San Diego Astronomy Association and subscribe because we also post our meeting notices for our monthly meetings on our social media sites. Additionally, if you'd like, or if you're a new member and you'd like to check out a telescope, we have a loaner program for our members. So you can go to the SDA webpage. And Dave, if you would put the link to that in the Zoom chat. So the link that you just see there, you can just copy that and paste it into the address bar on your browser, and it'll take you directly to our webpage on our website, where you can look at the types of scopes that we have and put in a request when we have available scopes to try out a new scope. A really nice thing to do if you're new and you maybe don't have a telescope, or you're thinking of trying a different kind of telescope and you'd like to see how that kind of works. So of course it's been complicated because of COVID and everything, but we're still doing that. And then also on our webpage, you can check out our latest newsletter. So in the December issue of our SDAA newsletter, we have an article on Jupiter and Saturn, which you may know are coming to kind of a nice conjunction in the sky. And Dave, if you'll go ahead and put the link to that. So there's all kinds of other interesting astronomy information that we put in our newsletter too. So again, you can just copy that link from the chat and put it into the address bar on your browser and take you right to that issue of our newsletter. So next slide, please. Oh, well, I just want to let you all know that if you're out doing astronomical observing in the cold weather now of winter, you may want a sweatshirt or a nice cap to keep your head warm. And we have a merchandise store where we have embroidered SDAA merchandise that you can purchase from the club, and it supports the club. And you see right there in the chat is the link. So you can either just click on it or just copy it and paste it into a browser window. So you can go check out the merchandise that we have on our store that supports our organization. Next slide, please. Yeah, so you may or may not know that we also, the SDAA has an, one moment please, has a YouTube channel. So you can go on YouTube and Dave, if you would paste the link to that in the chat. So we put all of our meetings up on our YouTube channel, so they're available to the whole public. And so if you miss a meeting, or if you want to go back and see what one of our great speakers has talked about, you can peruse the collection of videos that are already up there I checked a few days ago, and we had 958 different people gone and looked at videos on our YouTube channel. So please take advantage of that, all perfectly free. And so that's another great thing to take a look at. I just want to put in a plug that not only do our monthly meetings, do we put them up there, but we have also been doing live streamed outreach events from out in the field. And so there, we put those up now also on our YouTube channel. So if you want to go get the feel of what it's actually like in real time to go look at stuff in the sky from one of our outreach events, go take a look. There's a great one up there on Oak Oasis, and I think we may even have posted another one recently, more recently than that one, but please go ahead and do that. Next slide. Now we're going to get to our little segments. I pull things that I find on the web that are astronomy related. So this one is practicing with
This
the
is
lunar
Apollo
module.
Control, 97 hours, 36 minutes. We've had LOS at Canaries. Long past there in which we got the word that the CDH maneuver went very well. Gumdrop has reacquired Spider visually. We got an onboard reading from the reaction control system, 82% in System A, 75% in System B. And as we lost signal at Canaries, we were showing a range of 46.5 miles, a range rate of 105 feet per second and closing. Jim McDivitt and Rusty Schweikart continuing to feed radar information into the Spider's computer, continuing to update their solutions for the terminal phase initiation of this rendezvous. And as they progress on this, they are coming closer and closer to the ground solution. We passed up a pad for TPI showing time of ignition 97 hours, 57 minutes, 45 seconds. At that time, the onboard solution was reading 97, 57, 33. Just prior to LOS, they called out a new solution showing 97, 57, 41. This was in conversation between, air-to-air conversation between the two vehicles. The ground pad Delta V 22.3, the last solution on board 21.7 feet per second. Spider will continue to update his solution till shortly before he burns. We probably won't know which solution he went with until after the burn, but it looks like they're both going to be, that the onboard solution is going to agree very, very closely to the ground solution. This TPI burn, the times both ground-based and onboard, placed the burn just after loss of signal at Tananarive. That is the next station to acquire. Whether we'll be able to get good communications through Tananarive this time is doubtful, but we'll come up and stand by. Throughout this rendezvous, the flight surgeons have been monitoring just one pilot, and that's the stand by just a minute.
That's mentioned. This was taken with the film camera at 6
That's
frames
the lunar module pilot, Rusty Schweikart. His heart rate has been running between 58 and 70, with the majority of time down toward the lower figure.
And this occurred
You
over
heard
50 years ago.
Jim McDivitt talk. We have an Orion here. We may come up anytime. If we hear a call, we'll come back up. But you heard Jim McDivitt talking about the possibility of docking as soon as they rendezvous instead of station keeping for a number of minutes. The flight plan calls out that they'll station keep and then dock just prior to darkness.
You still got the target. Good. And the drove. Right there looks pretty good. Okay. Okay, you got it, huh? Not yet. Okay. Okay, I can't see my coax against you right now. Let me get up closer. All right. Okay, you've got the station keeping, right? I've got it. All right. Well, I've got to look to the top of my helmet and it might beat it up. You've got to come back quite a ways to your rear. Okay, easy does it. That's too far. Yeah, I know. Looks like a sporty little machine. Yeah, it's not even going the right direction. Houston, gumdrop. What time is sunset? Doing fine. Right there. Oh, that doesn't look like it's for me. So you're going to come in from an angle anyway, so you're doing good. Your yaw's off about 3 degrees. I just can't see the darn coax. I can't tell what my attitude is. Yeah. Okay, I'm lined up in translation, but I can't tell what my attitude is, Dave. If I don't see it, oh, there it is, there. Now you're coming in. That's good, looking better. There you go. I think you got a handle on it now. But it keeps disappearing. Okay, now you're looking pretty good. Okay, you're moving into the boundary now. You're inside the capture boundary now.
So I found this really interesting because it shows you how very manual things are. It wasn't like an automatic computer does everything kind of activity that you might think of as advanced spacecraft. And I think that was in part because this was over 50 years ago. This is like 51 years ago. And it was more, you can hear the people talking, the two astronauts, and they're like figuring it out as opposed to simply press the button and it does something that it's supposed to do. So that was a little long, but kind of cool. Give you a totally different feel for what space started as. So can you give me the next slide?
Immediately after the universe was born, it was too tiny and too hot for protons, electrons, and even photons to exist. Within a second, it had expanded and cooled enough for protons and neutrons, collectively called baryons, to form. Almost instantly, there was a rapid burst of sound waves triggered by tiny variations in this particle soup. Scientists call these waves baryon acoustic oscillations. The pressure waves traveled outward for 400,000 years until the universe thinned and cooled enough for light to travel through it. The universe became transparent, and the waves froze in place. Over time, the denser regions formed by the waves encouraged more star and galaxy formation than other areas. The imprint of those waves expanded with the universe, slowly accelerating due to dark energy. Today, with our snapshot of the universe, there is a slight tendency for galaxies to be separated from each other by a distance related to that expanding ring radius. Although difficult to see, it is detectable as a slight bump through careful surveys of many galaxies.
So you may have heard that they have used supernova measurements to try to measure the rate of expansion of the universe due to dark energy. And this method, the baryon acoustic oscillation method, is a totally separate method that has also been used to check and cross-check with those measurements. And they don't exactly agree with each other, and it's not exactly clear why they don't yet, but that's an area of active study. So next slide. I thought that was
in December 2018, after traveling for 2 years, 101 days, and over 1.2 billion miles, NASA's OSIRIS-REx spacecraft arrived at its target, near-Earth asteroid Bennu. OSIRIS-REx is the first mission to explore this primitive remnant from the origins of the solar system, designed to study the asteroid and return a sample to Earth. Bennu is a dark, diminutive world, roughly the height of a skyscraper, and now the smallest body to be orbited by a spacecraft. Prior to arrival, it was known to have low thermal inertia, a characteristic of fine-grained materials like sand. An infrared spectrometer on OSIRIS-REx confirmed this property, leading scientists to expect a predominantly smooth surface. But the first close-up views of Bennu delivered a major surprise. In exquisite detail, the mission's cameras revealed an unrelenting rockscape dominated by boulders. By combining these images from OSIRIS-REx with its laser altimetry data, we can take a tour of Bennu's remarkable terrain. The first stop is Simurgh Saxum. This prominent boulder defines the asteroid's prime meridian and serves as the basis of its coordinate system. In Persian mythology, the Simurgh is a large and benevolent bird and the possessor of all knowledge. Saxum is Latin for stone. To the northeast lies the largest boulder on Bennu. Measuring over 300 feet in length, Rock Saxum is a colossus longer than a football field. It is also rich in a type of iron oxide called magnetite, which was used by mariners as an early form of magnetic compass. In Arab folklore, the rock is an enormous bird of prey that can clasp elephants in its talons, as well as stranded sailors like the hero Sinbad. Continuing northeast over the equatorial ridge, we arrive at Gargoyle Saxum. This striking boulder is among the darkest on Bennu, though it clutches a much brighter rock that is about the size of a person. In medieval legend, gargoyles are dragon-like, winged monsters that can breathe fire and that guard cathedrals from evil spirits. Our next destination takes us far to the east. At the northern end of a small crater lies Ocypete Saxum, a comparatively bright boulder measuring about 33 feet in diameter. Ocypete Saxum is located near one of 3 sites where Bennu ejected small particles into space in early 2019, displaying its dynamic and evolving nature. In Greek mythology, Ocypete is one of the three harpies, the half-maiden, half-bird personifications of storm winds who would carry evildoers away from the earth. In the creation stories of ancient Egypt, the universe began as a formless, endless expanse of water. From this primordial sea arose the primordial mound, Benben. It was upon this rock that the god Atum settled in the form of the Bennu bird and sent forth the call that shaped creation. The story of Benben harkens to the mounds of fertile silt that once emerged from the receding floodwaters of the Nile, and it provides a fitting namesake for the tallest boulder on Bennu. Protruding by over 70 feet, Benben Saxum is so tall that it was first detected from Earth. Now, we can appreciate this monumental feature in detail using data from OSIRIS-REx. The final stop on our tour is a cluster of exceptionally bright boulders scattered across the southern hemisphere. They bear the spectral fingerprint of pyroxene, a mineral found in igneous rock that is unlikely to have formed on Bennu. These boulders most likely originated on the large asteroid Vesta and were delivered to Bennu's parent body through meteoroid impacts. Although it is small in size, asteroid Bennu has proved to be a fascinating world, abundant in geographic features that have defied our expectations. Thanks to OSIRIS-REx, we can now explore Bennu to uncover its composition, its evolution, and its ancient memories from the origins of the solar system.
So there's several different missions going on. Dave, if you can give me the next slide, that are looking at asteroids. The Japanese just had a sample return that came down in Australia a week or so ago. And there are also these that run from Earth from radar, which are do images, in this case with one of the radar dishes in Goldstone, California, and the other one is the Green Bank one is in West Virginia, and the data is combined to make a picture of an actual asteroid passing near the Earth. So I thought that was kind of cool. It's radar images tell you kind of different information, and they're done by a great deal of signal processing to get the type of images that you see here. And so they are essentially radar reflective, are the things that are light in this picture, and the things that are dark are radar absorptive or scattering. So that's another kind of different thing. Next slide, please. And many of our astronomers, instead of taking pictures of deep sky objects, often will take pictures with terrain and kind of very broad images. So here is a totally different thing I've never seen done before, and I thought it was kind of cool, where the images are stabilized on the Milky Way, and the camera turns the Earth. So I've never seen this kind of project where they essentially are taking, pictures every very long period of time, but they're doing it over, a day or more. So that's a kind of cool thing. So if any of you I know who like taking kind of landscape pictures with astronomy, might find that just an interesting project to try. So next slide, please. And I think that's was done in Australia, but I have to go actually look. So this is a coronagraph. So the central, you can see the central white circle, that's the size of the sun. And the bigger solid orange circle around it is the coronagraph that blocks out the crazy brightness of the sun, so that you can see that things that are running off the atmosphere. And I believe this was taken from the SDO, the Solar Dynamics Observatory, recently. So this was the end of November. So we're talking like 2 weeks ago or something like that. Yeah, like right around two weeks ago. And very strong coronal mass ejection, which is when it throws a lot of matter out into space. If those things hit us, it can damage satellites. It can pose health risks to people on the International Space Station if it's strong enough. They actually have special procedures they take to protect the astronauts. They categorize how big they are like we do earthquakes, and this is a magnitude 4.4 solar flare. So I thought that was kind of cool to look at it. You can go there. It turns out this satellite, which sits and stares at the sun constantly and issues weather warnings. And also if those things hit the Earth, you get the beautiful aurora as the particles thrown off in the coronal mass ejection get trapped in the magnetic field of the Earth and spiral in and hit the North and South poles. So I thought that was really cool. So, and then if you go to the next slide, actually it's not the last slide. So we got a question from one of our club members that they saw something and in the sky. And so you may see these things. This is an actual video taken from the ground of the deployment of the SpaceX space-based LEO internet system, the Starlink. And so right after Falcon 9 takes up, typically, I think it was 60. So we have one of our members commenting that they saw this. They release, I think it's roughly 64 satellites at a time, all in one orbit plane. And then they slowly spread out so that they make the distance between the satellites bigger and bigger until they're uniformly spread on an orbital plane around the Earth. And they're planning to use this to provide high-speed internet globally. So I thought that was really cool. And I think they're actually starting to try it out in some areas. And so I thought that was kind of fascinating. And since many of our members take these very long exposure pictures, you got to be aware that this kind of thing is something we have to deal with now. And I'm sure our guest speaker, Alex, might tell us if he's had to struggle with those lately. So if you can go to the next picture or next slide, please. So we have many members that take very beautiful pictures of astronomical objects. And here's one taken by Alan Ruckel of the moon. So, which is, just a gorgeous object by itself. On the right-hand side, you can see the text of the kind of equipment he's used to collect it, the type of camera, telescope, things like that. This is, of course, obviously a very bright object, so it's fairly quick to collect. The total exposure of this picture's like a second and a half. You can get very, very beautiful pictures of it, both it's a technically interesting thing to do with the hardware, software, technology, and the aesthetics of the beautiful pictures you get out of that. Next slide. We have another picture from a member of our organization, from Carl Weber. This is I believe this is the Crescent. Oh yeah, Crescent Nebula says right on the top of the picture. But this one is taken through a series of very narrowband filters looking at hydrogen alpha, oxygen 3, and sulfur 2. And he takes a series of 300-second images and combines them. And for hydrogen alpha, that's like 130 pictures he takes. And that's actually a lot of time. When you start adding those all up between those three colors, his total exposure time in this picture is nearly 26 hours, which is, obviously that has to be spread over multiple days just to collect the picture. And then most people end up spending about an equal, if not greater, amount of time on the image processing. So correcting non-uniformities in the camera, the telescope kind of thing, and then how to combine the images, since hydrogen alpha and sulfur 2 are both in the red part of the spectrum. Oxygen 3 is in the green, but they map them to different to red, green, and blue in almost a myriad of different ways. And there's a lot of aesthetic, almost artistic choices that are made to create this kind of image. So I thought that was a really nice thing, and our members create so many of these. So so that's another good one. And next slide. So tonight, the digital door prize for everyone is just a link to the Hubble downloadable image site. So Hubble maintains a site where they have all kinds of gorgeous images that you can just download and put up on your laptop screen, or make as your lock screen on your phone or things like that. And Dave, if you'll put the link in the chat for this, thank you. So you can just, again, copy that link and paste it into your browser, and it'll take you right there. They're all free. NASA maintains this just fantastic archive of imagery. And as you can see in the kind of this one thing, this is a picture of Saturn. So you're going to get some really great upload, gorgeous pictures of that. So that's your digital door prize tonight for everyone in attendance. And then I have on the next slide an announcement of a free course. And Pat Boyce, if you're there, would you like to say a few words?
Sure, I'd be happy to. We've been doing, Scott Dixon and I have been doing exoplanets now for 3 years. And we're involved in several exoplanet programs, 2 with NASA, and one at MIT and one at JPL. And they've evolved to the point that now it's really, particularly the new one at JPL, it's now come to citizen science. In fact, that's its focus. And we've been playing with that. There's new software for a year, working with them, and they're about to go into really the beta release for everyone. The real program will come out in mid 2021. And so we've got a class starting January 6th to get you capable of doing that. And you can participate in the final days of the development of this new worldwide project that they're putting up. And what you do is you learn how to observe and measure an exoplanet and report it into NASA's big database that's going to be used for targeting exoplanets by the James Webb and Europe's aerial satellites. Pretty exciting stuff. We're using the Center for Astrophysics at Harvard-Smithsonian has updated its entry-level exoplanet course to a do-it-yourself one. We use that to get our feet on the ground, and then we'll go in and actually do one of the ones that would go in and will go into JPL's Exoplanet Watch. When you're done in mid-February, you'll be able to do them yourself. Or you can do them with your own equipment or use our equipment to do them. We'll meet weekly at Wednesday nights and I have to figure out to deconflict it with SDAA's meeting times if there is a conflict. And then we'll be providing support to anybody that's interested. So all you do is, the link is in the chat. You'll learn more about the details of it and register for it. It's free if you want.
Okay, thanks.